Okay, here we're talking about measures of center in a distribution. The three measures of center are going to be mean, median, and mode. Mode, we already know, is a hump in a histogram. Now, the mode is always going to depend on what bin width you use for your histogram. If you use a smaller bin, you may get a different mode. If you use bigger bins, it's going to change your mode. So the mode is always histogram dependent. Different people drawing it may get slightly different modes. But generally speaking, here's a nice pretty histogram. I would say the mode is this hump here from 30 up to 70. Somebody else may say, no, the mode is from 50 to 60, and we would both be correct. The point is that the mode is just a bump in the histogram. Our next measure of center is called the median. That's the data point, the datum, that's right in the middle. If we have an odd number of data points, if our sample size is odd, then we'll have a leftover data point in the middle that we can point to and say, hey, that's the median. If we have an even number, like here we have 10 data points, then the median will be halfway between the two in the middle. So if I've got 10 and I want to split them in half, I would go 5 on the lower end, 5 on the upper end. So halfway between these two in the middle would give me 5 below, 5 above. So the median is halfway between these two in the middle. How do we go halfway between? We add them together and divide by 2. So the median is not even one of my data points. Sometimes it won't be. The median in this case is 48. That's halfway between these two numbers in the middle. Okay, now in relation to the median, something else we can bring up here that extends into the concept of spread as well are our quartiles. The median breaks the data set up into 2 equal halves. The quartiles break the data set up into 4 equal pieces, quarters, 25%. That's why they're called quartiles. The lower one we call the first quartile. It's the median of the lower half. Then the next quartile is called Q3. But what happened to Q2? We already have Q2. The median is Q2. The third quartile is Q3, and that's the median of the upper half of the data set. So for example, the same data set from before, the median was right here in the middle, breaking the data set up into 5 points below, 5 above. So here's our lower half, these numbers from 15 to 45. I want the median of this lower half. Now I have an odd number of data points, so I literally have one in the middle. The 32 here is literally in the middle. That's 2 below, 2 above. So Q1 will be 32. My upper half is from 51 up here to 80, these numbers. So Q3, the third quartile, is the number right in the middle because I have an odd number of data points. I have one I can grab. It's 68 right here. That's Q3, the third quartile. Okay, if we put the quartiles together with our min, max, and our median, we get what's called the 5-number summary. It's the minimum, the smallest number, Q1, the median, also known as Q2, Q3, and the max. So for this data set, the 5-number summary would be the minimum, Q1, which we just found a minute ago, Q2, or the median, Q3, and the max. This breaks our data set up into 4 equal pieces. Each of these spaces from 15 to 32, from 32 to 48, from 48 to 68, and from 68 to 80. Each represents 1/4, 1/4 of the entire data set. So 25% of these data points are between 68 and 80. 50% are between 48 and 80, because 48 was the median. 75% between 32 and 80, 100% between 15 and 80. So between here, Q1, and Q3, we have 50% of the data. Half of the data is between Q1 and Q3, the middle half, the middle 50%. 25% are below 32, 25% are above 68. Okay, the sample mean, our third measure of center. Here's some fancy mathy notation. The symbol here, X with a little bar on top, is read X bar, and that means the sample mean. We have a sample of 10 data points. We want to find the mean. When people say average in everyday life, this is what they're talking about. This symbol here is the Greek letter sigma, which means sum. X here means your data point, and N we know means sample size. So this just means add up all your data points and divide by the number you have, the sample size. So for this data set here, just add up all 10 numbers and divide by 10 because we have 10 of them. And that would give us 49.3 in this case. Okay, some notes about mean versus median. When is one better? When is one higher? If we have skewed data in a unimodal skewed distribution, the mean is on the skewed side. So if the data is skewed left, the mean is pulled to the left away from the median, and the mean will be less than the median. If the data is skewed right, if we got the long tail on the right, then the mean will be pulled to that side and will be greater than the median. Anytime we have skewed data, anytime, the median is the better, more accurate measure of where the middle is, the center. Skewed data has a large effect on the mean, has a very small effect on the median. If you have symmetric data, however, the mean is the better measure of center.